Hi, I'm Francesco Ragusa, a PhD student of the University of Catania, and today I'll present the MECCANO Dataset, Understanding Human-Object Interactions from Egocentric Videos in an Industrial-like Domain. With the rapid growth of interest in wearable devices in industrial scenarios, recognized human-object interactions can be useful to prevent safety hazards and to implement energy-saving policies. In the egocentric vision domain, previous investigations have considered the context of kitchens as well as daily living activity at home and in offices. Egocentric human-object interactions have not been previously studied in industrial environments such as factories, mechanical workshops, or building sites. In this work, I present MECCANO, the first dataset of egocentric videos to study human-object interaction in industrial-like settings. We asked 20 subjects to record egocentric videos while assembling a toy motorbike. The motorbike is composed of 49 components with different shapes and sizes, 2 tools, and an instruction booklet to understand how to build the toy model. You can download the dataset and its annotation at this link. An interaction in third-person vision is generally defined as a triplet in the form of human, verb, and object, where the human is the subject of the action which interacts with an object, and the verb describes the relationship between them. We define egocentric human-object interaction detection as the task of producing verb-object pair describing the interaction observed from the egocentric point of view. The human interacting with the object is always the camera wearer, while one or more objects can be involved simultaneously in the interaction. The goal is to infer the verb and noun classes and to localize each active object involved in the interaction. We considered 12 different verbs which describe the actions performed by participants to assemble the model of motorbike. We temporally label the occurrence of each object interaction indicating its starting and ending timestamp. A participant can perform multiple actions simultaneously. Indeed, the segments can overlap. We consider 20 object classes. Our object taxonomy comes directly from the parts and tools available in the toy model set used by participants. We spatially labeled active objects with bounding boxes inside temporal segments. Starting from the temporal annotations, we define 61 action classes. Each action is composed by a verb and one or more objects. The action labels follow a long-tail distribution. The MECCANO dataset is suitable to study a variety of tasks. The first task is action recognition, which consists in determining the action performed by the camera wearer from an egocentric video segment. The results suggest that action recognition with the MECCANO dataset is challenging and offers a new scenario to compare action recognition algorithms. The aim of the active object detection task is to detect all the active objects involved in interaction regardless of the object class. Training the object detector to detect only active objects in the scene already allows to obtain reasonable results, while there's still space for improvement. The active object recognition task consists in detecting and recognizing the active objects involved in the interaction considering the 20 object classes of the MECCANO dataset. Performance suggests that the proposed dataset is challenging due to the presence of small objects. In egocentric human-object interaction detection task, the goal is to determine egocentric human-object interaction in each image. The proposed task needs more investigation due to the challenging nature of the considered industrial-like domain. What's next? We will release MECCANO Multimodal, which comprises the RGB stream acquired with GoPro Hero 4 device, which has a larger field of view. The depth signal acquired with the RealSense camera, and the gate signal acquired with the Pupils device. GoPro stream, depth and gate signals are temporally synchronized with the RGB stream already released. We labeled all the active objects in the past frames related to the human-object interaction. Moreover, we annotated the hands in all frames in which active objects are present, already in the past frames. MECCANO dataset is the first dataset labeled with hands and future active objects, and it is suitable to study its relationship. In summary, we present MECCANO, a new challenging egocentric dataset to study human-object interactions in an industrial-like domain. We instantiate the human-object interaction definition in the context of egocentric vision and we show that the current state-of-the-art approaches achieve limited performance. Thanks for the attention.